Hey everybody, this is the video for the lesson from our Intro Calcs class this morning. That's Wednesday, December the 16th. And we are in implicit differentiation, and this is example 5. Examples 1 to 4 happened in the previous lesson. And we're using implicit differentiation to find the derivative of this equation. Now, I could still do this using method 1. I could expand that, which would give me a y squared and a y term, combine the y term with this y term, and then factor and solve this for y. But actually, now that I think about it, it actually would be kind of tough. It's probably going to be easier to use my implicit differentiation. I think method 2 is off the table for this one. So, with no further ado, here we go. I want the derivative with respect to x of this equation. So I always start by writing it out this way. All right, the left-hand side, I'm going to need chain rule for. So the 2 becomes a coefficient, right? That's this exponent is now here. And the exponent on this bracket now becomes 1 less than 2, which is 1. I don't need to write that down. But then I have to do the derivative of what's inside the bracket. The derivative of x is 1, and the derivative of negative y is negative dy by dx. On the other side of the equation, derivative of x is 1, derivative of y is dy dx, and derivative of 1 is 0. So there we go. We have now done the derivative of everything. This thing here is chain ruled right there, and this derivative of y is right here. And that one's there, and that one is there. We have done all the deriving we need to do. Get all these blues out of the way here. Okay, all right. Now what? Well, now I have to combine those two things and treat them like a variable. So if I have to combine those, I'm going to have to free this one from this bracket. So that's going to be my next goal, is I'm going to have to get that multiplied out. So I'm going to actually, I think first of all, the first thing I'm going to do is I'm going to multiply 2 into this bracket. So it's actually 2x minus 2y. And then, of course, I'm going to multiply that by 1 minus dy over dx and say that that's equal to 1 plus dy by dx. So, multiplying that out, I'm foiling here. 2x times 1 is 2x. 2x times dy dx is minus 2 dy, 2x times dy by dx. And then minus 2y times 1 is minus 2y, and minus 2y times negative dy dx is negative 2y dy dx. And all of that equals 1 plus dy by dx. Next, I need to collect like terms. I need to collect everything that has a dy dx as a factor into one place, and that's these 3 terms. Everything that doesn't have a dy dx in it is moving to the other side of the equation. So I will have, hang on a sec, I just realized I made a mistake. A negative times a negative is a positive. Huh, lost track of a negative there. All right, so I'm going to put that first, actually. The 2y dy dx minus 2x dy dx. And then this guy is moving to the other side. So minus 1 dy dx is equal to 2y minus 2x plus 1, right? This term and that term just moved over to here and here. Okay, I asked students in class today, can I add these together? Aren't they all like terms? They all have dy dx in them. No, they're not like terms because obviously that's a y, that's an x, and that's the constant minus 1. So no, they don't all add together. I'm going to have to do something else. What tool in my toolbox would allow me to isolate dy dx? And that tool is factoring. So I'm going to factor out dy dx, leaving me behind 2y minus 2x minus 1. Never forget that when you factor something out of itself, it leaves behind a 1. And that's 2y minus 2x plus 1. So I am now going to divide both sides of the equation by that big ugly bracket. And there we have it. That is the simplest expression I can get right now for the equation of the slope of, and what was the equation again? I've already forgotten. It was x minus y squared equals x plus y minus 1. Now, obviously, if this is a question for my homework, I'm going to like turn and see if that's the right answer in the back. But let's say that this was something I did in the field. I was out, I don't know, doing some sort of physics or something, and this was the equation I came up with, and I needed to know its slope at a certain point. I needed to know its slope just in general as an equation. How do I know that's right? Well, let's take a look at it in Desmos and see if we can play with it a little. So let me go to Desmos here real quick. Go to Google and, oops, oh, I thought I had Desmos open. Oh, there it is. Oh, that's for the other class. There we have it. I'm going to close those. Don't need them right now. And go to the regular home screen. And there we go. Oh, wait, that's too high. Where's the equation we were just doing? There it is, right there. There it is. I don't know, maybe that's maybe an astronomer got that equation. That looks very much like the way comets behave, isn't it? Very cool. So there we go. This is the orbital path of a comet as it approaches the sun and slingshots around it or something like that. Anyway, what I would like to be able to do is to check to see if my derivative is right. Now, unfortunately, Desmos doesn't do implicit differentiation. But here, I'm going to get around that. I can kind of click on this graph, and I can see that, hey, they're being nice to us. They're giving us its minimum. 0.875 and 0.375. Okay, let's go back to my work here. And okay, so I think this thing has a minimum at 0.875 and 0.375. Now I actually don't know if those decimals are rounded. I'm going to assume they're not and see if I'm right. Let's put them in as fractions. And if they're not rounded, those fractions should exactly, as xy, make this thing have some sort of slope. And actually, well, actually, let's take it to the original equation. The original equation should be a true statement if x and y are 7/8 and 3/8. So let's go to the original equation and plug that in. So 7/8 minus 3/8 all squared equals 7/8 plus 3/8 minus 1. That has to be a true statement if these exact points are on my curve. So 7/8 minus 3/8 is 4/8, which is a half squared as a quarter. And 7/8 plus 3/8 is 10/8. 10/8 minus 8/8 is 2/8, which is also a quarter. So yes, this is exactly a point on this curve. So yes, check is on curve exactly. And I would like to know what the slope is at that point. So I'm going to go to dx dy. So again, oh, hang on, let me just clear some room here. Oops. Okay, so dy by dx when x is, which one was x again? X was 7/8? Yeah, x was 7/8. So let's go to the formula here. So 2 times y, and y is 3/8, so 2 times 3/8 minus 2 times 7/8. And it's a plus 1 on the top? Yeah, it's plus 1 on the top and minus 1 on the bottom. 2 times 3/8 minus 2 times 7/8. Okay, so let's get a slope value at the point when x is minus 7/8, which is the minimum of this graph. Well, 2 times 3/8 is 3/4. 2 times 7/8 is 7/4 plus 1. And the bottom is 3/4 minus 7/4 minus 1. And if you add that up, you're going to get 0 on the top and negative 2 on the bottom, which is a slope of 0. And that kind of jives with what I noticed in the graph. If I look back to the graph, let's go back to Desmos here. When I'm at that point, yeah, that kind of does look like maybe the tangent there is a horizontal line because it has a slope of 0. Let's see if that's true. Y equals 3/8. Yep, it exactly makes a tangent. So I know that my derivative was right, and I know that I have the slope right. Cool. Let's do one more example. Example 6, find the slope of that. Okay, so once again, it would be really hard to isolate that y, so we're going to do this using implicit differentiation method 2. So the derivative of this thing is, so the derivative with respect to x of x squared plus, I should probably put that in a square bracket. x squared plus curved bracket y minus x cubed. Oops. Well. Equals 28 is going to be 2x plus 3 times y minus x all squared. Again, where did that come from? Chain rule. And then what's the, I have to do the derivative of what's in the bracket, which is dy by dx minus 1. And all of that is going to equal 0 because the derivative of any constant is 0. All right, now what do I do? Yeesh. Well, I need to isolate dy dx. Is there any point to foiling that out? And the answer is no. Don't bother. After all, this is the thing I want to isolate. Expanding that just makes more terms. Doesn't actually help me any. So I'm going to leave that alone. I'm going to move everything over here one piece at a time. So 3 is y minus x squared times dy dx minus 1 is equal to negative 2x. Then I'm going to divide both sides of the equation by this thing. And then I'm going to add 1. There, I've got a slope. There. That's my slope. And this time, I want to know the slope when x is 1. So, you know, the first thing I should probably do is find out the y-coordinate. So when x equals 1, the y-coordinate on the curve is, so that's x squared plus y minus x cubed. So that's x squared plus y minus x cubed equals 28. Step 1, minus 1 from both sides. Step 2, cube root both sides. And then last step, add 1 to both sides. So the actual point is the point 1, 4. And let's find dy by dx when x is 1. And I already know that the y is 4, so that's negative 2 times 1 all over 3 times 4, forgot the bracket there, minus 1 squared plus 1. So that is equal to negative 2 over 3 times 3 squared, so 27 plus 1, which is, 1 is of course 27 27, so that's 25 27ths. So I have a point, I have a slope, I have an equation. I actually only really wanted the slope. This is the answer. Find the slope. Found it. But I want to check and see if my answer is right. So I'm going to make the equation y minus 4 equals the slope of 25 27ths x minus 1. And then I'm going to go back to Desmos. And I'm going to actually graph that. So there's the curve. It's one of these speed bump curves with a little bit of a twist in it. There's the point. Oops. Go back. There's the point that when x is 1, and I want to know if my derivative is right, the slope I used at 1 makes a tangent line at the dot we just graphed. Is this a tangent? Yep, looks pretty tangenty to me. Let's zoom in on it. Yep. So we know, oops, oh, I just moved the point. Oh well. We know we did it right. Okay, so go back. There we go. We know we did it right. And that's it. That's the 2 examples for today.